So our next speaker is going to move us into the construction side of the world and the sort of engineering aspects of how water is currently handled and maybe some thoughts going forward of other opportunities. We are joined by Laney Nelson. Laney is a senior water engineer in the San Francisco office of ARUP, a global collective of designers, engineers, and sustainability consultants and advisors. Her primary expertise is in the planning and design of water, wastewater, and stormwater infrastructure. Before joining ARUP, she worked on a wide range of modeling, planning, and design projects as a consulting engineer at Woodard & Curran. And she was educated at Cal Poly San Luis Obispo, my alma mater, receiving her Master's of Science there. So I'm excited that Laney will be able to bring her design and engineering expertise this morning. So please join me in welcoming Laney Nelson.
Thank you. Hi, everyone. Can you hear me okay? Great. Thank you for the introduction. My name is Laney Nelson. I am from ARUP. I'm going to talk today about some water resource management concepts and groundwater, and talk about some technical challenges and opportunities with that. I know this is a hot topic, so. Introducing myself, like Rick said, I went to Cal Poly, bachelor's and master's. I studied civil engineering. I worked at a few consulting firms. At Cal Poly, I was part of Engineers Without Borders, and that's really what got me into the water resources field, because when you look at places that have a lack of all kinds of infrastructure, the first thing they need and the thing they need the most help with is water and sanitation. So I felt like it was the most meaningful thing I could do with my degree and with my career, which is what sent me to this path. On the daily, what I do is I do flood risk modeling and design, water conservation and efficiency and reuse studies, which we'll talk about a lot of today, and some stormwater management design. Like I mentioned, I'm a senior water engineer at ARUP. ARUP is a global consulting firm. We have offices all over the world, a bunch of people. I'm from the San Francisco office, so I flew down this morning to be here, and I'm so glad. My first time in West Hollywood. Thank you for having me. We also have an office in Los Angeles. You might have seen our building. It has our name on it, which is pretty cool. So at ARUP, we are a owned and trust, which means that we do what we want to do, and what we like to do is sustainable development. So at ARUP, we say sustainability is everything, and we work really hard to try and assess and meet the UN Sustainable Development Goals in all of our projects. So what we're going to go through today is talk about some water resource concepts, integrated water management, which includes things like stormwater management and reuse, and gray water and black water reuse and recycling. Then we're going to get into some details and definitions on groundwater, and talk about dewatering, which I know everyone is super interested in. And I'll kind of define some terms and let you know how that works, and we'll talk about some technologies and mitigations. So first, let's go back to the basics. Some of you might have seen the water cycle in your 5th grade science class. This is a little more complicated than that, but basically it is rain falls onto the land, it either percolates into the groundwater, into the soil, or it can run off into surface waters like lakes or rivers, and then to the ocean eventually. From the ocean or surface waters, it evaporates back into the sky and then happens all over again. So the main point here is remembering that the water systems is a cycle, and that if you don't know where the water is, it's somewhere in the cycle for sure. So where is our water? About 97% of it is in the oceans. It has salt in it, so only about 3% is what we call fresh water, and of that, even smaller percent is what we think of as a normal surface water source, like lakes and whatnot, only about 1%. There's a little more of that in groundwater, but for context, like there is a lot of water in the world, it's just, if you don't know where it is, it's probably somewhere else in the cycle, it's probably in the ocean. So Kim did a really good background of water supply in West Hollywood. I have a couple slides on this, but I'll be brief on that. I just really like this LA Department of Water and Power figure that shows kind of where the imported water sources are from. The Colorado River Aqueduct, which Kim talked about, and also some from Northern California, where I'm from the LA Aqueduct and the California State Water Project. But there's also a great little pop-out showing the local water sources, which includes stormwater capture, groundwater, and water recycling. And those are really what I want to focus on today, because those are kind of part of the integrated water management that I'll be talking about. So before we talk about integrated water management and that strategy, I think it's really important to define some terms that we've probably heard, but maybe don't know exactly what they're defined as. So potable water is water that is safe for drinking and showering. It's what comes from your municipal source, it comes right to your tap when you turn the water on. That's called potable water. Non-potable water is exactly how it sounds. It's not drinkable, but it could be used for things like toilet flushing or watering plants. And then gray water and black water are both terms to describe types of wastewater. So gray water is wastewater that comes from sinks and showers. It doesn't include any like organics from kitchen sinks or sewage from toilets. Gray water would include all the wastewater, including that sewage from toilets and whatnot. And so those two terms together are what we would call wastewater. So now that we know about those things, I can get more into the strategy of what we think of as integrated water management. So this is basically the thought process on how to manage your water sustainably and holistically through the water cycle. Some of you might have heard the term net zero in context of GHG emissions or energy, things like that. We also use net zero as a term for water use. So when you're trying to get to net zero, or when our clients are trying to get to net zero, what we try to do is say, how do you offset all of your potable demands from somewhere like a municipal source? And you either reduce your demand, so that's through conservation and efficiency, or you look at alternative supplies, which would be like stormwater reuse, gray water recycling, and black water recycling, or things like groundwater recharge, groundwater reuse. So conservation and efficiency are definitely the easiest ones, the ones that people know the most about, but there's only so much that you can reduce your demand. You have to use some water. Even places like Las Vegas, where their water use is so low, I don't even know how they do it, you have to have some kind of alternative supply or offsets to get to that net zero. So I'm going to talk a little bit more about those today. Starting with stormwater management and reuse, I really like this figure. It's from the EPA. And stormwater management and reuse, I think that there's going to be some other panelists talking about, managing stormwater through green infrastructure and those kind of things. So I'm just going to focus on capturing and reuse today. So that's basically capturing water from rainfall, or if that already has fallen onto the streets or parking lots, putting it into a tank. In a building like is shown in the figure, the tank would probably be kind of like these big ones shown in the bottom right corner. And then for a residential, maybe a single family home, you might have something more like a rain barrel, which is shown on the top, where you can just capture the water from your rooftop, and then you can reuse that for things like watering your plants. Like Rick mentioned, there are water quality considerations with stormwater. Usually if it falls on a rooftop, it's cleaner than if it falls on something like a parking lot where there's car greases and whatnot. But usually there's some kind of treatment that's necessary, especially in bigger developments and buildings like this. So on to gray water reuse. Gray water reuse is capturing the gray water, which we talked about earlier, where it would be from washing machines and sinks and showers, and putting that into a tank and reusing that for things like irrigation or toilet flushing. This does require some water treatment, probably a little bit more than for your stormwater, depending on what's in that. And then another thing that you could do is black water recycling. So that would include all the wastewater from your building. This requires even more treatment than gray water. It's kind of like a mini water treatment plant that you would have at your municipal system. I know Kim talked about heat island effect and everything getting hot. Well, what do we do when it gets hot? Turn on our air conditioners. Black water recycling and recycling of that water can be used as a non-potable use for cooling towers and cooling buildings. So it's a really good alternative supply for things like that. So some of you with a really keen eye might have been looking at this figure and seeing this green arrow on the bottom and saying, are we really letting groundwater into our basements and then we're reusing that? Awesome question. I will get to that in a second. But first, we're going to talk about some of the more basics of groundwater so we're all on the same page. So groundwater, like we talked about, is water that falls from the sky, lands on the ground, and seeps into the soil and rocks underground. So an aquifer is the name for that soil and rock underground where the water lives. A water table is the shallowest level of groundwater, and it's what we talk about. We say we have a high groundwater table or we have a shallow groundwater. Depending on your perspective, they're the same thing. And then a well is something that's drilled into the ground to withdraw or pump water from aquifers. There are, municipal drinking water wells, which usually dive pretty deep. But you can also, have recharge wells, which are shallower. So when you pull water up from the ground, pumping through wells, it removes the water from the spaces between the rocks and soil. When you remove the water from those spaces, sometimes the rocks and soil can compact on each other, and it can lead to groundwater subsidence and settlement of the ground. So one of my favorite shocking and crazy photos is there on the right. It's of land subsidence in the San Joaquin Valley. Basically, there's been a bunch of historical groundwater pumping and overdraft in that area, which people probably know about. But from 1925, there on the top, to 1977, the actual ground actually sunk about 9 meters, or 6 or 7 of that little guy in that amount of time, which is a huge amount. And once the ground subsides, the aquifer is shrunk and there's no more room for water to be recharged back in. So there's nothing you can do after that point. So the hot topic of the day, groundwater dewatering and groundwater in construction. So as we've talked about, groundwater in West Hollywood is relatively shallow, or there's a high water table. So when you go to construct a building that has a basement or an underground parking garage or something like that, you are gonna run into some groundwater usually. Just like if you're, digging a hole on a beach, you're gonna find groundwater there. And the really important thing to note here is that groundwater in this construction process can be really unsafe for workers, and it also makes it really difficult, near impossible, to actually build what you're trying to build. So in order to figure that out, you have to do the process called dewatering, which is removing groundwater from that site to provide a safe and stable environment for excavation. So how does this work? There are 2 different ways you can do it. One of them is blocking, which is where you would build a barrier or a cutoff wall around the area that you're trying to dig out. That would direct the water around that area, and then you could have dry and stable soil to excavate. It's usually something like concrete, you just shoot it into the ground. The other way you can do it is by removing groundwater, which is what we're thinking of now of dewatering, where groundwater is pumped out so that in that local area, the groundwater table is lower so that you can dig that out. The important thing for this process is that you stay within your sustainable yield of the whole groundwater basin as a whole. So groundwater basins are huge. They kind of manage themselves in that they have recharging systems. They have surface waters and rainwater and things like that that are recharging them, and then there's also water being pulled out. So because they're so large, they do a pretty good job of maintaining their water levels. So what dewatering does, if it's within a sustainable yield, it only drops the water table at it's called the cone of depression around the well locally. So if you're within your sustainable yield, you're not decreasing the groundwater table in the whole basin. That would be bad. So it can lower that groundwater table in the nearby area though, and the other thing is that it has to be discharged somewhere. So where is that water going? Some of you have seen it. So some of the disposal methods that are really common are on-site reuse. So you can just take that water, store it in like a little makeshift pond or a tank or something, and you can reuse it for your needs during construction. That would be something like dust suppression, so spraying down piles of dirt so that it's not getting everywhere and ruining your air quality. That's a really good use for it. Sewer system discharge and disposal to surface water both require, permits and mandatory testing to make sure that the quality of that water is good enough to be going into those areas. And then you can have off-site discharge where you basically put the water into trucks, you truck it away somewhere else where it can be, reused, or it can be stored or treated or anything. Really important considerations for this are, like I said, the water quality. If there's nearby users that can use the water, and then the potential impacts. So what are some things that we can do if we think that there's going to be impacts to, local people around? So one thing you can do is you can recharge the water back right to the groundwater where it came. So this reduces the need to discharge, so you don't have to worry about any of that. You can usually just not treat it and put it right back in because it's going right where it came from. The only issue with this is that it has to be quite a large site because you can't put the water back right next to where it came out, or else that would ruin the whole purpose. So this is something that's very commonly done, though. And then the other thing, bringing it way back to this figure that we talked about before, is we talked about temporary reuse of dust suppression or for irrigation, but you can also use that water for permanent reuse after the construction is finished. So this green arrow showing that you can let water into your basement and capture it, you can capture it and treat it and use it for things like cooling a building, especially for a building that's large like this. So a really cool example of that right nearby is the Cedars-Sinai Medical Center. I drove by it on my way here from the airport. This project actually pumps and treats groundwater at sustainable rates for reuse at their cooling towers. This has helped reduce the medical center's use of city-supplied water by 29 million gallons annually, which is equivalent to supplying 267 single-family homes. So key takeaways that I want to make sure that we all understand is that, in order to manage your water resources sustainably, you need to look holistically through the water cycle. And reusing water is a great sustainable alternative supply. Another thing is that dewatering is often necessary, especially in places with high water table, to make construction safe for workers and to make it so you can actually build the building. But groundwater can be pumped at rates that are sustainable and don't degrade or deplete that resource. And it can also be managed in smart ways to protect those local conditions, like reusing, recharging. Thank you so much. Let me know if you have any questions. I put my LinkedIn and my email there. Thanks.
Thank you. Thank you, Laney. We do hope that you are thinking of some questions because we imagine at the end of these presentations we'll have a nice, robust conversation. And I suspect construction specifics to West Hollywood might come up as well. So we'll be looking forward to that.